Good morning. My name's Charlie Baum, and today we're going to discuss production. We're going to examine how the production process works, and I'm going to discuss how to determine the cost of producing output. Let me begin this topic with a couple of definitions. First of all, we're going to have two kinds of inputs that are used to make output. Output is going to be what's sold to consumers in the marketplace, and inputs are going to be those resources that are used to make the output. Some of our inputs will be fixed, and some of our inputs will be variable. Variable inputs are inputs that change with output. We can increase output by increasing variable inputs. Fixed inputs are those inputs that cannot change. They are fixed during the period of time that we're considering. So output cannot be increased by increasing the quantity of fixed inputs used in the production process, because fixed inputs by definition are fixed. The next set of definitions I'd like to provide you with are those for the short run and the long run. The short run is a production period that is so short that some of the inputs are fixed and some of the inputs are variable. The long run is a production process period when all inputs become variable. Since the long run is a longer time horizon, firms have the ability to change the quantities of all the inputs they use in the production process. So again, in the long run, all inputs are variable. In the short run, at least one input is fixed. So this leads us to calculating costs. Since there are two kinds of inputs, fixed inputs and variable inputs, this means that there are two kinds of costs, fixed costs and variable costs. Fixed costs are going to be the costs of the fixed inputs, and variable costs are going to be the costs of the variable inputs. So if we add those two kinds of costs together, fixed costs and variable costs, then we'll get total costs. So you see that in the slide in front of you. Total cost equals variable cost plus fixed costs. Now if we let output be a variable referred to as Q, then we would be able to divide variable costs and fixed costs by quantity in order to get average fixed costs and average variable costs. These averages are going to be on a per unit of output basis. So for example, if you divide fixed costs by quantity, then you get average fixed costs. And if you divide variable costs by quantity, then you'll get average variable costs. Similarly, we could divide total costs by the amount of output we're producing, and this would give us the average total cost of production. Since total costs equal fixed costs plus variable costs, this means that average total costs equal average fixed costs plus average variable costs. I'm going to show you a table where we actually calculate some of these costs. First, let me indicate what the two inputs are that we're using in the production process. One of the inputs is workers, and the other input is ovens. Now, in this table, you'll notice that we're producing output, and the output is pizzas. So this is a production process for a restaurant. You'll notice that more pizzas can be produced. We can go from producing 0 pizzas all the way up to producing 640 pizzas as illustrated in this table. But pizzas are produced, and the quantity of pizzas are produced using these two inputs, ovens and workers. You'll notice that ovens in the table are fixed. That lets us know that ovens are a fixed input. The quantity of workers changes. It goes from 0 to 6. So this tells us that workers are the variable input. So we can increase the quantity of pizzas that we're producing from 0 to 640 by increasing the quantity of workers that we're using. But you'll notice that ovens stay fixed at 2. Okay, the first three columns of the table describe the production process. The next 7 columns in the table are going to describe the cost of production. For example, we're going to assume that the 2 ovens cost $800, and we're going to assume that each worker costs $650. So on the first row, we're using 2 ovens, and this is going to cost $800. On the second row of the table, we're still using 2 ovens, and so this is going to cost $800. This is the total fixed cost of production. And since the fixed inputs stay fixed, the total fixed cost stays fixed as well. It stays at 800 across all the rows because output stays fixed at 2. I'm sorry, the quantity of the fixed input we're using stays fixed at 2. However, variable inputs are increasing with output, and you'll notice in this table that the quantity of workers we're using increases from 0 to 6, and so the cost of the variable input increases. If we're using no workers, the variable cost is 0. If we're using 1 worker, the variable cost is $650. If we're using 2 workers, the variable cost is $650 times 2. That's $1,300. So if you multiply 3 by $650, you'll get the variable cost for the 3 workers. Then, if you'll add together fixed costs and variable costs, you'll get total costs. These are averages, and the same thing is true for totals. If you add together the fixed costs and the total variable costs, then what you'll get the total cost of production, the total cost of the pizzas. So for example, 800 plus 0 is 800. 800 plus 650 is 1450. 800 plus 1300 is 2100. So we're adding together fixed costs and variable costs to get total costs. Then if you take these 3 total cost columns and divide by quantity, what you'll get are the next 3 columns, which are average cost columns. For example, fixed cost divided by quantity equals average fixed cost. Let's look at that. If we divide 800 by 200 pizzas, this is the output, then we'll get an average fixed cost of $4 per pizza. If we divide fixed cost of 800 by 450 pizzas, then we'll get $1.78. Similarly, if we wanted to calculate average variable cost, we would divide variable costs by quantity. For example, 650 divided by 200 is $3.25. 1,300 in variable cost divided by 450 is equal to average variable cost of $2.89. Now, to get average total cost, there's really 2 ways you could do this. One way would be to say average fixed cost plus average variable costs equal average total cost. That's this formula right here, and we discussed it on the prior slide. Another way you could get average total cost would be to take total cost and divide by the quantity of output. For example, 1,450 divided by 200 pizzas is an average total cost of $7.25. Let's do one more row. Total cost of $2,100 divided by 450 pizzas is an average total cost of $4.67. Alternatively, I could say $1.45 in average fixed cost plus $3.54 in average variable cost equal average total cost of $5. And this is the same as a total cost of $2,750 divided by 550 pizzas. The last column I want to show you is the marginal cost column. To calculate marginal cost, you identify how total cost changes with each additional unit of output that is being produced. For example, if we're producing no pizzas, then the total cost is $800. If we produce 200 pizzas, then the total cost goes up by $650. If we divide $650 by 200 additional pizzas, then we get a marginal cost of $3.25. Let me do one more of these. Let's suppose that we are producing one pizza for $1,450. If we produce, we're producing 200 pizzas for $1,450. If we produce 450 pizzas, the total cost is $2,100. So you would take the difference in total cost, which is $2,100 minus 1,450, and divide that by the additional pizzas being produced. There are 250 additional pizzas being produced in between these two rows, and the additional cost is $650. So $650 divided by 250 is $2.60. So doing one more of these, in order to get a marginal cost of $6.50, you subtract total costs and divide by the additional pizzas being produced. Here there's 100 additional pizzas being produced, and the total cost goes up by 650. So 650 divided by 100 is 650. Last, I want to graph these curves, and what you'll notice is that the average total cost curve and the average variable cost curve are U-shaped. They go down at first due to increasing marginal returns, but eventually they both start rising. Both average costs start rising due to diminishing returns. The marginal cost curve is going to cut through the minimum point on the average total cost curve and the average variable cost curve. For example, if you identified the minimum point on the average total cost curve and the minimum point on the average variable cost curve, the marginal cost curve would intersect these curves at those points. The marginal cost curve goes down due to increasing returns, and it goes up due to diminishing returns. The marginal cost of production increases because each additional unit of the variable input is producing less and less additional pizza. And let me also graph for you the average fixed cost curve. This one is a little bit different. It is going to asymptotically approach the x-axis, which is where cost is 0. This is because we're dividing a fixed, a constant fixed cost by a larger and larger quantity. The fixed cost stays the same, but the quantity of output gets bigger and bigger and bigger, and so this average cost goes to 0. Let me point out one other thing. Average fixed cost plus average variable cost equals average total cost. So if you add average fixed cost to average variable cost, you should get average total cost. Since average fixed cost is getting closer and closer to 0, that means we're adding less and less average fixed cost to average variable cost as output increases, and so the result is that the average total cost curve and the average variable cost curve get closer and closer together. The more output you produce, the closer these two curves get together, and the reason is because you've got less and less average fixed cost to add to average variable cost to get average total cost.